Hi, this is the second part of the video on the electrolysis TYS paper 2. Okay, for this question, so the difference from the expected ratio is greater when the electrolysis starts, but less noticeable after the electrolysis has been running for some time. So suggest why this happened. Because at the start, right? So because at the start, there is very little oxygen in the solution. So a lot of oxygen that produced will dissolve in the solution. Yeah, so we can say at the start, there is little oxygen in the solution. That means in the sodium chloride solution, in the aqueous sodium chloride in the solution. When there is very little oxygen in the solution, what will happen? Okay, when there is very little oxygen in the solution, what happens is a lot of oxygen that is produced will be able to dissolve in it. So a lot of O2 produced will dissolve in the solution. So as the electrolysis progresses, okay, as the electrolysis progresses, the solution will become more and more saturated with oxygen. Progresses, the solution become saturated with oxygen. Hence oxygen produced can't dissolve in it. That's why at the start a lot of oxygen dissolve. So at the start a lot of oxygen produced here dissolve in the solution. That's why you can see there is a big difference. I mean the ratio of hydrogen to oxygen would be a lot more than 2:1. But as electrolysis progresses, there is more and more oxygen in the sodium chloride, which means that the oxygen produced can no longer dissolve in it because it becomes more and more saturated with the oxygen. So that's why as electrolysis progresses, the ratio would be closer to 2:1. At the start, most of this oxygen produced dissolve. Okay. Now, what happens to the concentration of sodium chloride during the electrolysis? So you can see as electrolysis progresses, H plus and OH minus will discharge, leaving behind Na plus and Cl minus. So which means that the concentration of the sodium chloride will increase. Yeah. So you can say as H plus and OH minus discharge, the concentration of NaCl, of Na plus and Cl minus increases. Hence, concentration of NaCl increases. So you have to explain it step by step. Okay, I write in short form, concentration. Alright. Okay, the same apparatus can be used to electrolyze concentrated aqueous sodium chloride. Concentrated aqueous. Give one similarity and one difference between the products of the electrolysis of dilute and concentrated concentrated aqueous sodium chloride. So this one is H plus, Na plus, Cl minus, OH minus. So what will discharge? This will discharge as well as, because this is concentrated, so it affects the discharge of anion, which means that in this case Cl minus will discharge. Okay, so what will be the similarity? The similarity is hydrogen is collected at the cathode for both the electrolytes. So at the cathode, same thing. Hydrogen is collected. And then what will be the differences? The differences is for aqueous sodium chloride, oxygen is collected at the anode. While for concentrated aqueous sodium chloride, chlorine gas is collected at the anode. Okay? And again, for the real O-level paper, you have more space to write. Okay, so this one is very similar to the answer provided in the answer scheme. Okay, platinum metal electrolytes are used. Why is platinum a suitable material for use as an electrode? So platinum is an inert electrode, meaning that platinum is an unreactive or inert metal. What does it mean? It means that it will not react. That won't react with the product. Okay, with the product of the electrolysis. Okay. It is inert, won't react with the products of the electrolysis. So that's why it is a suitable material. So another answer given by the answer scheme is that it is a good conductor of electricity. Yeah, actually a better answer will be this one, the inert unreactive metal. Okay, let's look at the last question. Okay, the last question, concentrated, so products of the reaction at the positive electrode. And again, list down the ions. Carbon electrode. So what will be the product of the reaction at the anode? At the anode, concentrated, so it's chlorine gas. So this one is chlorine gas. Okay, dilute. Dilute is the same. I mean, it's a very similar. SO42 minus, OH minus. Okay, at the negative electrode or the cathode. Okay, this is copper electrode. So copper electrode, remember, this is like electrolytic purification. Electrolytic purification, what will happen is the positive electrode will ionize, and then at the negative electrode, the cation will be attracted to it. At the negative electrode, the cation will discharge to form copper. So this is like electrolytic purification because both electrodes are copper. Okay, so the copper actually move from anode to the cathode. And then, okay, the last one is actually molten. Okay, molten sodium chloride. Molten sodium chloride, you only have Na plus. This one don't have, and Cl minus. So the Cl minus would discharge at the positive electrode, and then the sodium ion will discharge at the negative electrode. Molten, because if it is concentrated, Cl minus will discharge at the anode, and then for the cathode, that H plus will discharge. So this one should be molten. Alright, thank you very much. Bye bye.